Greetings to everyone. This presentation is about AICTE Research Promotion Scheme entitled as Improvement of Power Generation in 20 kilowatt Solar PV Power Plant through Bypass Diode Scanning Algorithm and Modified Couple Matching Algorithm. Project duration is 22nd November 2019 to 22nd November 2022. Principal Investigator Dr. D. Prince Winston, Professor, Head of the Department of EEE in Kamaraj College of Engineering and Technology. The total amount granted is 1,50,000 rupees. We thank AICTE to grant this amount to enrich the research facilities in our campus. These are the list of major components which are purchased through this scheme. The first one is wireless solar power meter. The second one is MPPT charger controller. The third one is solar microgrid inverter, that is standalone inverter, followed by the solar power meter, and these are the lead acid batteries rated as 12 volt 7Ah, and this is the charger for the batteries. These are the list of consumable items. The microcontroller is FPGA controller, and these are the solid state relays, and most of the components are IGBT, power IGBTs, and inductors, transformers, which are used for our research work. This is the special type of batteries, which is polymer battery, lithium ferrophosphate battery, rated as 48 volt and 15 Ah. This is mainly used for our research work. Then these are the some of the list of publications which are published with the help of this under this scheme. The first one is parallel power extraction technique for maximizing the output of the solar PV array. In this work, we done is under the partial shading condition, the mismatched power can be extracted with some external load in the backside operation. Hence, in this technique, the parallelly the power of extracted from the front side as well as the back side. This work got published in Solar Energy Journal in the publication of Elsevier. This journal impact factor is 5.472. Then this paper got the citation of 17 up to this. The second publication is a novel on-time partial shading detection technique for electrical reconfiguration in solar PV system. This is the modified couple matching technique. In conventional couple matching technique, they were used the current sensor. In this technique, we use voltage sensor. The main advantage of this system, of this work is without isolation of the load, we can predict the partial shading, and we can reconfigure the PV array to enhance the power under the partial shading conditions. This work is also got published in Solar Energy Journal in the publication of Elsevier. This paper got citations of 3, and this journal is also have the impact factor of 5.742. And the third publication is analysis of voltage and current mismatch in photovoltaic power plants during the fault panel replacement system. In this work, we done is the voltage current mismatches in the specification of the PV module, which are replaced instead of that faulted PV module. At that time, what are the difficulties faced by the investors by replacing the faulted panel with the new panel with the different specifications? Due to these conditions, the power losses also be there. Under this case, how we can improve the power in the PV array. This work got published in Energy Sources Party, Recovery, Utilization and the Environmental Effects in the publication of Taylor and Francis. This journal has impact factor of 3.447. Recently, this paper got published, so this paper got none of the citation as per now. Then the final one is patent filing. A patent is entitled as a circuit arrangement and a method for generating power using solar PV. In this patent, we claim that in the solar photovoltaic array, to eradicate the partial shading scenarios, we can incorporate the batteries in each row, connected parallel to each row of the PV array, to enhance the power under partial shading condition. In this case, the partial shading condition is exactly nullified by the external power source like batteries. The mismatch loss is almost equal to 0 in this work that we claimed, and also we filed the patent for this innovation. For all those things, Real-time implementation also be done in 1.5 kilowatt solar PV array, which is a small part in that 20 kilowatt large scale PV array. In this case, some faulted PV modules are connected in the 1.5 kilowatt PV array with the help of switching matrix circuit and solid state relays to reconfigure the PV array to enhance the power with the faulted PV module in the PV array.
This is the 1.5 kilowatt solar PV array. Consists of 6 250 watts PV modules are connected in series through switching matrix circuit. This switching matrix circuit consists of solid state relay controlled by the Arduino Uno microcontroller. The Arduino Uno programmed in Arduino programming. There are three switches, three manual switches are used to change the switch modes to reconfigure the PV array. In this PV array, some PV modules are get faulted due to certain aging problems or due to some micro cracks. So in order to rectify that, the switching matrix circuit reconfigure the PV array. In switch mode 1, in conventional mode, the power output of the PV array is 495 watts nearly through the MPPT charger controller. So in order to enhance the power, we need to change the switch mode to 2. In this mode, the nearly 615 watts power is obtained. So in this mode, the faulty panel gets isolated through the switching matrix circuit. Then in switch mode 3, the faulty modules gets parallel with the one healthy module, and this parallel combination connected in series with the array. So in this condition, nearly 620 watts the maximum power will be obtained.